We will now implement our resource server in our Elastic Query service. Let's first add Spring Boot Starter Oauth to resource server dependency by using it under specified Spring Boot version. We need to remove starter security and then use this new dependency instead. Then we will update the configuration file config client Elastic Query and then add Spring Security Oauth to resource server configuration variable to set issue URI and GW key set URI and set those values to the key clock URIs defined in the key clock configuration. As you see, we use microservices realm which defined in key clock section. For GWKS URI, we added protocol OpenId Connect certs to the end of the issue URI. Then we will update web security config, which is currently configured for HTTP basic authentication. But before that, we will create a security package and add the required classes that we will use in the security configuration. First, I will create Twitter Query User class that implements user details interface from security core. This interface has methods like getUsername and getAuthorities that will provide us that information. We will use builder and getter Lombok annotations in this class, and then create username as string and authorities as collection of granted authority, and return the corresponding values in get methods. Also return true for remaining get methods like isEnabled, as we will not implement that logics here. For password, let's create a class constants and create a constant NA and return it here. Finally, let's create the setter for authorities only, as we will need it to pass the parsed authorities from JWT into the user details object. Let's then create Twitter Query User Details service class that is marked with service annotation and implement User Details service here. This User Details service is also from Spring Core library, and here we will override loadUserByUsername method, which will take username as parameter and returns user details that we defined. This method, loadUserByUsername, will be called during authentication of client, and we will implement the logic to load the username by adding the authorities and permissions we want to include. Note that in our example, we will already be added authorities by parsing JWT, and here we will only fetch the object level permissions. Stay tuned, I will update this method in the next section to include user permissions. For now, let's just include username and return Twitter Query User object. Then I will create another class, Audience Validator, with qualifier Query Service Audience Validator to implement Oauth Token Validator with JWT as generic type, and annotate it with component annotation. We will implement validate method here that takes JWT as parameter and return Oauth Token Validator result. I will now create a custom audience property in Query Service configuration and update Elastic Query Service config data class. Then we can inject this config data in the audience validator and check the audience value we added in the key clock configuration. If we have the correct audience defined in JWT, we will return Oauth Token Validator result success, otherwise failure, with an Oauth error object. We will use this validation and add it to our custom JWT decoder. Alright, we can now create Twitter Query User JWT Converter class that implements converter with generic types JWT and abstract authentication token, and override convert method that takes JWT as parameter and return abstract authentication token. We will first inject Twitter Query User Details service here. I will then define some constants that will refer to claims in JWT. We will define realm class claim, roles claim, scope claim, username claim, and also some constants for defaults like role prefix, scope prefix, and for a scope separator as a single space. I will now create two methods to get authorities from roles and scopes. GetRoles methods will get roles claim from realm access claim using JWT and iterate over the collection of strings defined in that claim to create a list of role authorities using role prefix. So here we map the authorities to role underscore authorities with uppercase and then collect to list and return. In case we don't get a collection in roles claim, we will return an empty list. GetScopes method will get scope claim and iterate over the collections of strings defined in that claim and create a list of scopes using scope prefix. This time we used scope separator, which is space, to get the scopes as array, and then map them to authorities using scope underscore prefix. Again, if scope claim is not a string, we will return an empty collection. Now we will define a getCombinedAuthorities method to combine the results from those getRoles and getScopes methods. And finally, we will create getAuthorities from JWT methods. Use getCombinedAuthorities method to get a collection of authorities as string, and map them to simple granted authority and return a collection of granted authority object. Great, we can now complete the overwritten convert methods. Let's call getAuthorities from JWT here, and get all the authorities we want. Then call the Twitter query user details service load by username method by passing the username claim we defined as constant, which is preferred username. We then set the authorities into the user details object, and then map the results to username password authentication token object by passing the user details that returned from load by username method. Username password authentication token also requires password and granted authorities again as parameter. So let's pass them, and for password let's pass constant NA. I use object of nullable as wrapper here, and in case we have null response, I will throw bad credentials exception with a message user couldn't be found. Alright, now we can return to web security config class. First, I will remove enable web security annotation and instead add enable global method security pre-post enable true annotation to enable pre-post authorization annotations to use them in method level. We will then remove user config data and instead inject Twitter query user details service and Oauth resource server properties objects. Then start changing configure method with HTTP security parameter. First call HTTP session management and set session policy as stateless. Then disable CSRF, and then authorize request, and for any request enable full authentication, and then enable Oauth resource server. And finally for JWT, use a custom JWT converter with a method. We will now create a bean in this method and return Twitter query user JWT converter by passing the user details service as the parameter. We will then create another bean with method JWT decoder that takes Oauth token validator audience validator as parameter, with qualifier query service audience validator. We used qualifier annotation here to be able to inject the audience validator that we created. We will use JWT decoders from OIDC issuer location methods and pass the issuer URI by getting it using the Oauth resource server properties getJWT method. Then cast it to Nimbus JWT decoder, where Nimbus is the underlying library that Spring Security uses for handling JWT operations. Here I will create a Oauth token validator with JWT validators create default with issuer methods, again passing the issuer URL from JWT, and then create another validator with delegating Oauth token validator class, and pass the issuer validator and also the injected method parameter, which will inject our audience validator object. Then we will set this delegating validator into the Nimbus JWT decoder. Note that by default issuer validator also adds timestamp expiration validator automatically. Here we additionally added an audience validator on top of default validators. Great, we will now go to controller and add a pre-authorized annotation on the class level and use isAuthenticated method inside the pre-authorized annotation, so that we will only serve to authenticated user. Then for more specific authorization checks, I will update getDocumentByText method and add pre-authorized annotation with hasRole and hasAuthority methods inside it. Here we will accept the request only if user has role up user role or has scope up user role. If you remember the up underscore user definition on Keycloak, we have defined the role up underscore user underscore role for this user, and also defined the same role for the client scope. So this role will come with the realm access claim, and if we check the custom JWT converter, we are adding it to Spring Security Authorities by adding role prefix. So that means our user will have the role up user role. And if we check the hasRole method in security context folder await request wrapper, it adds the role prefix to the parameter, so we can use it here without adding the role prefix. That's great, but if we wouldn't use custom JWT converter, only the scope up user role will be added to authorities, which comes by default as Spring Security Authority from the scope definitions on JWT. So I added a OR statement to pre-authorize annotation to call hasAuthority method with this default scope also. We can use any of these hasRole or hasAuthority checks. Here both should return true. Alright, now I want to test this, but I don't have a client yet that has a browser interaction so that I can use authorization code flow. So for test purpose, we can use resource owner password credentials flow, which is, as mentioned, is an insecure way of using Oauth as we share the user credentials with client. But for test purposes, I will use it now, and replace it with a secure authorization code flow in the next section when we implement OEDC compliant web client. So let's first commit and push config server changes as we always do. Then we will use this curl command with a post method with grant type password. Here we pass username and password as well as client ID and secret, which we can get from the Keycloak admin console in client section as we defined there. And for the URI, we use the token endpoint from our OEDC server, which is Keycloak. So it is URI microservices realm protocol OpenId Connect token, where we can obtain the token. This should return an access token, and we can use it to call our query service with an authorization bearer header. Let's run Elastic Cluster locally and config server, and then run Elastic Query Service. And get an access token from the Keycloak with the app user using this curl command, and then use it to call to query service get document by text endpoint on Postman by passing the authorization bearer header with the access token. And we get the response. That's great. As you see with the curl command, we get the access token as well as a refresh token and the scopes that is valid for the current user. Refresh token can be used to get another access token when the access token expired, instead of initiating a flow from scratch. Now if I change the user to app admin instead of app user to get a new token, and call the get documents by text endpoint, we will get an authorization error because this method now requires app user role. Since app admin user doesn't have this role, we will get access denied error. As you can see, we have the rows under realm access, we have the preferred username for username, we have the scopes, audience and other claims. Here one interesting point is that JWT.Oauth can even validate the signature, but how? It uses the issue URI in JWT and adds /protocol /OpenId Connect /cert URI to obtain keys from our local Keycloak server. It works with Chrome, but it will fail for Safari, for example, because Safari doesn't allow to call local addresses from browser. In the next section, we will add a database connection to fetch user permission on object basis and then update our security config with that. I'll see you in the next section.